Greetings, Briggsdalians. Um, we are virtual today, so let's look at the next lesson, which is going to be 7.3 out of your book. I have the worksheet online, so if you don't have your book, you're going to be okay. You don't need to print the worksheet out. We're just going to look at some concepts out of the book and apply them to the worksheet as we go along. Today we are trying to prove that triangles are similar. Now you might remember that previously in our book we were looking at congruent triangles and we had some shortcuts. Those shortcuts were side, angle, side, 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 angle, HL, etc., etc. And we want to try and have some shortcuts for similarity as well. There's a lot of similarity here to showing that they're congruent. But remember, similar things are different sizes. The first one we want to look at, and then remember, these are shortcuts, okay? These are shortcuts to showing that triangles are similar. And so the first one is really simple. It's sort of related to angle, 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 except we only need two angles. Because if you think about it, all the interior angles when added have to be 180. So if we know what two of them are, then the third one we would know as well, right? And that reasoning sort of goes along with angle, angle. If you can demonstrate that the angle and its corresponding angle here are congruent, and that this angle and its corresponding angle over here are congruent, then we should already know that the third ones are going to be congruent as well. And as long as all three angles are congruent, then the triangles are going to be similar. So it's only necessary to say that two angles in one triangle are congruent to two angles in the other triangle, and then we can say the triangles are similar. Okay? Remember, we're talking similar today. Similarity. Oh, a very fuzzy image right there. Haha, better. Our second shortcut is a side angle side similarity theorem. Now we had a side angle side that was a congruency theorem, but this one is going to be side angle side similarity theorem. And what do we need to know here? Well, we need to know that two sides are in the proportion that we're looking for. Remember the similarity ratio that we just talked about in the last lesson? Well, that similarity ratio is going to be the same for two, right? Two of our sides in our triangle. So, for example, if AB over QR, right? If that ratio was the same as AC over QS, and at the same time the included angle, remember included angles are the ones that are between the sides, and the included angle of this triangle is congruent to the included angle of this triangle, then those triangles are going to be similar. Once again, if the ratio of AB over QR, if that ratio is the same ratio as AC over QS, and remember those are fractions, so we can simplify them. But if those are equal to each other, and the included angle between those sides is congruent with the two triangles, then we can say those triangles are similar and make this similarity statement. All right, so we got two, angle, angle, side, angle, side. Our next one is called side, side, side. And then this one, remember, I'm going to go backwards just a little bit. When we talked about this stuff yesterday, we said that we needed to check to make sure that all of the angles were congruent. And then we needed to go back and check to make sure that all the side ratios were the same. But this one tells us that if we're looking at triangles and we can show that all the side ratios are equivalent, that's enough. We call that the side-side-side similarity theorem. So we'll look back up here and go, well, if AB, when we build a fraction of length AB over length QR, if that's the same ratio as length AC over length QS, and that those ratios are also the same as length BC over length RS, then that's sufficient to say, hey, these two triangles are similar. And that's our similarity statement right there. That's the similarity statement. Groovy, groovy. Well, we've got some things that we can put into use on our worksheet. By the way, the worksheet is attached in Google Classroom. It is also an attachment on the lesson planner. So you should be watching the video. You should be grabbing a copy of that worksheet, which you do not need to print. They're just showing us pictures that we can use to write down on papers where our answers are, okay? So looking at this picture, it says determine whether the triangles are similar. And if so, write a similarity statement and name the postulate or theorem that we use. Well, let's see what happens. If I look at this drawing, I see these two lines are parallel to each other. And I see that they're being cut by a transversal. And I know from before that alternate interior angles are congruent. So I can say that angle A is congruent to angle D. Okay? And I know that this angle here and this angle here are vertical angles. And I know that vertical angles are congruent. So I could say that these two triangles are congruent by the angle-angle similarity postulate, right? So I'm going to say AA. Now that I've determined whether or not they're similar, I need to write a similarity statement. And that just is one that says triangle ABE is similar. Remember, there's our symbol for similar. Is similar to triangle DCE. Keep in mind that the order matters here. Angle A corresponds to angle D, right? Those two were the same measure. Those two got listed first. So if I list B second, which angle corresponds to B? Well, C is going to correspond to B. And then angle E corresponds to angle E. All right? That is called the similarity statement. So there we go. Number one's done for us. Determine whether their triangles are similar. Yes, they are. We used angle, side angle, or we used angle, angle, I should say. And then we wrote our similarity statement. There it is. Groovy? Groovy. If I take a look at number 2 here, and remember what our shortcuts are. The first one was angle, angle. And if you're interested in looking them up, they're all listed on 2 pages in your book, if you have it. Page 450 says angle, angle. Page 451 says there's a side angle, side similarity, and there's a side, side, side similarity. So if we look here, do we have 2 angles like we did in the first one? Can we show that 2 angles are similar? No. The other postulate was called the side angle side similarity theorem, right? So we got to find a side, an angle, and a side. Now the side lengths have to be in the same ratios. Do we have any side information here? Well, this is congruent to that. Okay. But that's all I got. So I don't think I have two sides. I can't use side, angle, side. And if I don't have two sides, I certainly don't have three sides, so I can't use side, side, side. So unlike number 2, you say not enough information. Not enough info, man. Just don't have it. Do we know anything about these? I'm looking at 3. Do you see 2 triangles? Sometimes it's kind of hard to see them. But L and M is one triangle, right? It's right there. And then there's a smaller triangle right here. ONP is another small triangle. Both of these triangles have a shared vertex right here. N is in both of them. And N's congruent to itself, right? And then we know that these two lines are parallel, don't we? And we have names for like angle M and angle P here. What kind of angles are those? Those are corresponding angles. That should help you with 3. I'm not going to give you much more information about that. Let's take a look at 5 real quick. I'm looking at 5 and 10. Those are corresponding sides. And they're in a ratio of 5 to 10. Which if we simplified it, we would get 1 to 2. And if I look at 14 and 28, well, that's a ratio of 14 to 28, right? And if I reduce that, I also get 1/2. Okay? So this side ratio was the same, and this side ratio was the same. And we were given that this angle and this angle are both right angles. I want you to notice that that angle is included between the two sides. That angle is included between those two sides. So I have side, angle, side, don't I? And I'll leave you to write your answers down because you're also going to have to write the similarity statement. But that's how you might use something like side, angle, side. Okay? Okay. Let's look at a proof. Oh no, proof. Scary. Why would you want to do a proof? Number 7. We'll do should we do number 7 or number 8 together? Which one should we do together? I guess maybe we'll do 8 together, and I'll let you guys go back and see if you can do 7. 8 maybe looks like it might be harder. I don't know. But let's write down some information. It says that A bisects JK. What that tells us is that that segment and that segment are the same length. And then it tells us that C bisects KL, so that that segment and that segment would have the same length. And then it tells us that B is bisecting JL. So that tells us that this segment and this segment are the same. Excuse me. And then it says, hey, can you show that JKL, that's the big triangle, is similar to CBA to CBA? Well, I don't know. Well, let's find out. Now, earlier in the quarter, we learned about mid-segments. We had a mid-segment theorem. And the mid-segment, if you recall, is a segment that connects the midpoints in a figure, okay? The midpoints of the side. So here, A is said to be a bisector. So this is the middle of JK. And C is a bisector, or the middle of KL. And when I connect A to C, this becomes a segment, a mid-segment, okay? And the mid-segment theorem said that that segment that connects the midpoints will be parallel to the side, okay? So AC is parallel to JL, and half of its length, okay? So the ratio here, I'm just going to build some information here, that AC is to JL, right? Whatever that ratio is a 1 to 2 ratio because AC is 1/2 of JL. Okay? Now it's also parallel. So we could get some information about the angles here if we needed to, right? Let's think about this. BC is also a mid-segment, isn't it? It's a mid-segment and is parallel to JK, this side over here. And how big? That's right, it's half as big. In other words, BC to JK is also a 1 to 2 ratio because BC is half the length of JK. But we have a third mid-segment, and that's AB here. AB is also a mid-segment, so it's parallel to KL. And if I were to look at that ratio, I could say AB to KL is a 1 to 2 ratio. Let's build a proof, shall we? Do you see a proof coming up? Can you see how we can say that JKL is similar to CBA? Yeah, I hope so, because we had one of our theorems, right? One of our theorems says I could show that all three corresponding ratios here, right? If I take AB, if I take this side of this triangle and put it over this corresponding side of the other triangle, then it would have to be in the same ratio as AC over QS, right? Or this side of the triangle to its corresponding side in the other triangle. We're building these ratios. If they're the same each time, then we can say the triangles are congruent. Are not congruent, are similar. So we're going to do that. Starts off and says A bisects JK. That's just the first statement in my given. A bisects JK. At the same time, I can say, and I'm going to write all these together, C bisects KL. And at the same time, again, these are the ones that are the givens in here, right? B bisects JL. And all of those are given. So I'm just going to list all my givens right up front. Yay! Well, what does that mean? As I said before, that means that I can connect those midpoints to make mid segments. Right? I'm just going to go number 2. By the way, working on problem number 8, right? Problem number 8. First step was list the given. Second step, I'm going to say AC is mid segment of JL. Okay? AC is the mid segment connected with JL, right? And AB, yeah, let's do AB first. AB is mid segment of KL. Same reason. There it is. AB, mid segment of KL, right? That is, it's parallel to KL, and it's going to be half its size because that's the whole idea, right? And the last one, then BC, is mid segment of JK. Look at the picture. Okay? What that really means for us, and by the way, I'm going to go, okay, reason number 2, that's the definition of mid-segment, right? All right. So, now I can go ahead and say, okay, just like we were saying before, just like I wrote down, because I was writing my little notes here going, I wonder how we can do this. I'm going to write each of these ratios down. Okay? AC over JL is 1/2. AC over JL equals 1 to 2 ratio, right? At the same time, BC to JK as a ratio is 1 to 2. At the same time, AB to KL is 1 to 2. And again, that's just copying what we were talking about before. Those are that's a mid-segment idea, right? We call that the mid-segment theorem. So, dun. 3 mid-segment theorem. That the length of a mid-segment is half the length of the corresponding side, right? Mid-segment there. They're all 1 to 2 ratio. Hot diggity dog. Well, what that means is that AL to JL is the same as BL to JK is the same as AB to KL. Why? Well, we could use substitution, transitive, what do you want to call it? when I say substitution, multiple uses of substitution. Hey, if this is 1/2, then I can and then if this is equal to 1/2 and this is equal to 1/2, then I can substitute that in for the 1/2. And the same thing going on over here, right? So we'll finish this up and go. We can now say triangle JKL, that's what we're trying to do, is similar to triangle CBA. And the reason I'm saying that's because that's what we're supposed to be proving right there. Why is that true? Side, 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 similarity. Right there. Side, 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 similarity. Okay? Groovy. All right. I'm going to let you guys look at the rest of this. It's kind of just a lot of doing that kind of thing. For number 10, you're going to have to set up the fact that you've got some numbers in there so you can set up the ratios and find your unknowns. Similar to what we were doing yesterday. And the rest of these just kind of doing the same kind of thing. Here we can like even tell how tall the pyramid is. Groovy. Proportions. Cool. All right. So good luck with that. Work on that worksheet. If you have questions, you can email me. All right. Other than that, have a groovy day. Enjoy your snow day. And we'll talk to you soon. Bye-bye.